Hello students, welcome to Educate. In this video, we will discuss about bonding in coordination compound. In the previous classes, we have already discussed about the introduction about the coordination compound, the nomenclature in the coordination compound and the isomerism in the coordination compound. Now, we will discuss about the bonding in coordination compound. Various theories has been proposed to explain about the bonding in coordination compound, and these theories are valence bond theory, crystal field theory, ligand field theory and the molecular orbital theory. Valence bond theory, crystal field theory, ligand field theory and the molecular orbital theory. In your syllabus, the valence bond theory and crystal field theory is included. Now let's see valence bond theory. Firstly, what is valence bond theory? Obviously, the valence orbital participate in the bond formation. The valence bond theory explain about the shape of molecules and also explain the molecule will be diamagnetic or paramagnetic. That means the valence bond theory explain about the shape of molecules and the magnetic behavior of molecules. Valence bond theory explain about the shape of molecules and second one is the magnetic behavior of molecules. Molecules means coordination compound, the molecules of coordination compound, the shape and the shape of the coordination compound and the magnetic behavior of coordination compound. This one will be better. On the place of molecule, it will be better to write the magnetic behavior of coordination compound. Now, we will explain one by one. That means here, the coordination of the magnetic behavior of compound, that will be diamagnetic, or paramagnetic. Okay, now let's see, we discuss about some compounds in coordination compounds. Let's see. Firstly, we will discuss about the bonding in CONH3 whole 6. Bonding in CONH3 whole 6 3 plus. CONH3 whole 6 3 plus. We will have to discuss about bonding in the compound CONH3 whole 6 3 plus. You know the coordination compound have covalent compound has the directional property. So for the shape of the molecules, the covalent bond will be responsible. CONH3 whole 3 plus plus, that means molecule may be Cl3 or any, that means balancing will be like that. But to predict the shape, only this bond is covalent. So this one coordination sphere will have the role for the prediction of the shape, because this bonding will be ionic bonding. So let's see about bonding in CO. So when that has been dissociated, so that become CONH3 whole 6 and here 3 plus. About that we will have to discuss in the bonding. So let's see how to do that. Cobalt, you know the atomic number? The atomic number of cobalt is 27. So electronic configuration, this one is the electronic configuration of cobalt atom. The oxidation number of cobalt here is what? +3. How? You may find out. CONH3 whole 6 it is. So X is for cobalt plus 6 ammonia, and ammonia is a neutral molecule. That into 0, that equal to +3. So X equal to +3. So oxidation number of cobalt is +3. So we will have to write the electronic configuration of CO3 plus. So to form CO3 plus, 2 electron from 4s will lose, and 1 electron from 3d will have to lose. So then after, electronic configuration will become this one. That will be the electronic configuration. Now let's see what happened here. 3d6 means here 3d6 here, so there will be 4s also. 4s orbital is there. There is no electron, but orbital will be there, and 4p also. So that means you can also write 4s then after 0 and 4p 0 here. So here is 3d orbital. Six electron. So 1, 2, 3, 4, 5, and this will be paired. This is the electron of 3d, and this is 4s. When the ligand ammonia approach will approach towards CO3 plus, then pairing of electron, that means these electrons will get pair up. Here is 4 unpaired electron, so they will pair together. So the pairing of electron. Pairing of electron will take place. So here is 4 electron. So then after, when the pairing will be there, then 2 orbital will become vacant. This electron come here, this electron come here. So these are 2 electron orbital will become vacant. So that will be here. This 6 electron here will come, and here 4s. This is 3d, 4s, and here 3d. Oh, 4p. This one. Then coordination number is here 6. Coordination number is 6, and they will have to form 6 sigma bond. 6 ammonia is bonded to cobalt. That means coordination number is 6. So there will be 6 hybrid orbital will require to form the covalent bonding, 6 covalent bonding between ammonia and the cobalt. So to form 6 sigma bond, 6 hybrid orbital will require, and to form 6 hybrid orbital, 6 atomic orbital will have to merge together. Listen again. The coordination number here is 6. That means 6 sigma bond will have to form. To form the 6 sigma bond, 6 hybrid orbital will require. And to form 6 hybrid orbital, 6 atomic orbital will merge together to form 6 sigma bond. 6 atomic orbital will merge together. So the 2 orbital of 3d, 1 orbital of 4s and the 3 orbital of 4p, they all will merge together. So d2 inner d orbital has been participated here in this complex. The inner d orbital has participated in hybridization. So hybridization will be d2sp3. That means the 6 hybrid orbital having the hybridization of d2sp3 will form. So now this d2sp, the 6 d2sp3 hybridized orbital will spread in the space, so that when electron will be there, they will experience the least repulsive force. The 6 d2sp3 hybridized orbital will arrange in 3-dimensional space around the cobalt, so that when the electron will be present in those orbital, they will experience the least repulsive force, and that will be when this orbital will arrange in octahedral geometry. So there will be formation of d2sp3 hybridized will be there. So there will be formation of 6 d2sp3 hybridized orbital. Its hybridization is d2sp3. 6 d2sp3 hybridized orbital will form, and they will arrange in 3-dimensional space, so that the electron present in those orbital will experience the least repulsive force. Now in this 6 hybrid orbital, the ammonia molecule will donate their lone pair of electron and will be bonded there through covalent bond. So shape here will be shape will be octahedral. Main here is shape and magnetic behavior. Magnetic behavior. Watch out here in the molecule. There is no any unpaired electron. Here also, the electron has been paired up. In the molecule, there will be no any unpaired electron. So that's why this molecule will be diamagnetic. So this molecule will be diamagnetic molecule. Now you tell me here, it will be here since inner d orbital has been participated in hybridization. The inner d orbital has been participated in hybridization. That's why this complex will be called inner orbital complex or low spin complex or spin paired complex. Since the inner orbital has been participated in, since the inner 3d orbital, since the inner d orbital has been participated in hybridization, that's why the complex will be called inner orbital complex or low spin complex or spin paired complex. Okay. Okay, clear here? Why it is called inner orbital complex or low spin complex or spin paired complex? Because pairing of electron has been taken place. That's why spin paired complex. Low spin complex because here spin is less, and inner orbital complex since inner d orbital has been participated in hybridization. That's okay. That was bonding in CuNH3 whole 6. That is shape will be octahedral, and that will be diamagnetic. The complex will be called inner orbital complex or low spin complex or spin paired complex. Okay. Now we will discuss about the bonding in COF6 3 minus. So now we discuss about the bonding in COF6 3 minus. This one. Let's see. Same here. The electronic coefficient of cobalt we will have to write. Cobalt atomic number 27 as now. What's the oxidation number of cobalt? You find out here x plus 6 into minus 1 that equal to minus 3. So x equal to plus 3. So oxidation number of cobalt here is plus 3. So cobalt we will have to write the electronic coefficient is plus 3 oxidation state. So 2 electron will release from 4s and 1 electron will release from 3d. So electronic coefficient will become now what is here? The fluoride ion is a weak field ligand. The fluoride ion is a weak field ligand. That's why it will not induce the pairing of electron in 3D. When pairing of electron will not take place, then what will happen? This one 3d orbital, yes, 6 electron here. So pairing of electron will not take place here, and here coordination number is 6. In CuF6 3 minus, the coordination number is 6. That means the cobalt will have to form 6 sigma bond. The cobalt will have to form 6 sigma bond. So to form the 6 sigma bond, the cobalt will need 6 hybrid orbital. Cobalt will have to form 6 hybrid orbital, and to form 6 hybrid orbital, the 6 atomic orbital will have to merge together. So what to do? Here pairing of electron in CuNH3 whole 6, due to the pairing of electron, the 3d orbital had participated in hybridization. But here what is how the hybridization will take place? So there be 4p is here, so that means 4d is also here. Here 4d is also here. This one is 4d orbital. So what happened? To form 6 sigma bond, the bond orbital of 4s, 3 orbital of 4p and the 2 orbital of 4d will merge together. The 1 orbital of 4s, 3 orbital of 4p and the 2 orbital of 4d will merge together and will form sp3d2. 1 orbital of s, 3 orbital of p and 2 orbital of d. That's why hybridization will be sp3d2. So sp3d2 hybridization will take place here. So there will be 6 sp2 hybridized orbital, 6 sp3d2 hybridized orbital will be there. In this sp3d2 hybridized orbital, the fluoride ion F minus, that means here 8 electron. This F minus will donate their electron and will be bonded with CO3 plus through covalent bond. So in these 6 sp3 hybridized in these 6 sp3 due to hybridized orbital, the fluoride ion will donate their lone pair of electron, a pair of electron, and will be bonded with covalent bonding. So here the outer d orbital has been involved in bond formation. That's why this complex will be called outer orbital complex. Okay, and here there is already unpaired electron is there here, 4 unpaired electron. So that's why that will be called high spin complex. High spin complex, or that will be also called spin free complex. So this complex will be called outer orbital complex because the outer d orbital has been involved in bond formation. Outer orbital complex because the outer d orbital has been involved in bond formation. It will be called high spin complex because in this complex there will be a number of unpaired electron and it will be called spin free complex. Okay, shape will be here, shape of the molecule will be octahedral. Now this molecule will be paramagnetic since there is unpaired electron, so it will be paramagnetic. And this complex will be called outer orbital complex or high spin complex. And that will be also called or spin free complex. Shape of the molecule will be octahedral since outer d orbital has been involved in bond formation. The outer d orbital has been involved in hybridization. That's why will be called outer orbital complex. There is a number of unpaired electron. That's why that will be called spin complex, and or that will be also called spin free complex. Okay, that was about the bonding in COF6 3 minus and CONS3 whole 6 3 plus. COF6 3 minus and CONS3 whole 6 3 plus. About that was amount of bonding. Now let's see the bonding in the molecules in which the shape will be tetrahedral, like NiCl4 2 minus. NiCl4 2 minus, about that we discuss. So nickel firstly, atomic number 28. So electronic configuration will be now watch out the oxidation number of nickel. Nickel, suppose X plus 4 chlorine and oxidation number of chlorine considered as -1, that equal to -2. So X minus 4 equal to -2. So X equal to +2. So in +2 oxidation state, you will have to consider about their electronic configuration. So 2 electron will release from 4s. So electronic configuration will be of Ni2 plus. That will be this one. Now let's see about the electron in the orbital, d orbital. Eight electron. So let's see. This one here. Now coordination number of nickel here is 4. That means nickel will have to form 4 sigma bond. Here nickel will have to form 4 sigma bond with chlorine. 4 sigma bond with chlorine. So to form 4 sigma bond, there will be requirement of 4 hybrid orbital. And to form 4 hybrid orbital, the 4 atomic orbital will merge together. Here Cl minus, as F minus was a weak field ligand, like that Cl minus here also is a weak field ligand. So the weak field ligand will not induce the pairing of electron. As F minus was a weak field ligand, like that Cl minus is also a weak field ligand, and that will not induce the pairing of electron in in Ni2 plus. So what will happen? It will have to form sigma bond. So what to do? One orbital of 4s and the 3 orbital of 4p will merge together and will form sp3 hybridized orbital. Okay, so one orbital of 4s and 3 orbital of 4p will merge together and form sp3 hybridized orbital, and here the 4 sp3 hybridized orbital will form due to the merging of one orbital of 4s and the 3 orbital of 4p. The 4 sp3 hybridized orbital will form. In this 4 sp3 hybridized orbital, the Cl minus here will donate a pair of electron. In this 4 sp3 hybridized orbital, the Cl minus will donate their pair of electron and will be bonded through covalent bond. So in these hybrid orbitals, one Cl minus, in this hybridized orbital, other Cl minus, in this one other Cl minus, and in this one other Cl minus. One Cl minus will donate their electron and will be bonded through covalent bonding. In this sp3 hybridized orbital, the other Cl minus will donate their electron and will be bonded through covalent bonding. In the same way, here another Cl minus and here another Cl minus. So that means the 4 Cl minus will donate their pair of electron to the sp3 hybridized orbital and will be bonded through covalent bonding. So when hybridization is sp3, so shape will be tetrahedral. And now magnetic behavior what will be? Now what will be the magnetic behavior? In this molecule there is two unpaired electron. That means in this molecule the Ni2 plus is containing 2 unpaired electron. That's why the molecule will be paramagnetic. The molecule will be paramagnetic. Okay, meaning a shape and magnetic behavior. Now in another molecule like tetracarbonyl nickel, we will have to discuss now about the tetracarbonyl nickel, about this molecule, tetracarbonyl nickel. About this molecule we will have to discuss. So let's see how the bonding is taking place here in tetracarbonyl nickel. Let's see here, carbon monoxide is a neutral molecule. Now electronic configuration nickel, nickel atomic number 28 as usual. This one. Now let's see, nickel oxidation number of nickel is here is 0, X plus. Carbon monoxide is a neutral molecule, so that will be 0, X equal to 0. So oxidation here is in 0 oxidation state. Here it is 0 oxidation state. So 4H2 here. Then after during the bond formation, this electron will fall into this one. So this 3d orbital will become fully filled. When carbon monoxide will come here for the bond formation, the electron from 4s will fall into 3d and all the electron will become paired. And coordination number here is 4. Coordination number is 4. That means nickel will have to form 4 covalent bond. So to form 4 covalent bond, the 4 atomic orbital will merge together. And to form 4 atomic orbital, so 1 orbital of 4s and the 3 orbital of 4p, that will merge together and form sp3 hybridized orbital. So here 4 sp3 hybridized orbital. In this sp3 hybridized orbital, the molecule carbon monoxide bond is like this. The molecule carbon monoxide will donate their electron, and it is sp3 hybridized orbital. The carbon monoxide molecule will donate their electron and will be bonded through covalent bonding. So here shape will be tetrahedral, shape tetrahedral, and magnetic behavior. What will be the magnetic behavior? In this molecule, there is no any unpaired electron. So that's why molecule will be diamagnetic. Molecule will be diamagnetic. Clear? Now let's see another compound. In the compound tetracyanoto nickel. So let's see here. So what happened here? Nickel, same. Atom number 28. Now let's see the oxidation number of nickel. Here how much? Nickel, suppose X plus. There is 4 cyanide group and oxidation number Cn minus here. So minus 1, that equal to minus 2. So X minus 4, that equal to minus 2. So X equal to plus 2. So here nickel in plus 2 oxidation state, what will be their electronic configuration? So 2 electron from 4s, that will release from the nickel, and the nickel will convert into Ni2 plus. So here Ni2 plus here. So electronic configuration will be then after. What happened when Cn minus is a strong field ligand? Cn minus is a strong field ligand. So it will, when Cn minus will approach towards Ni2 plus. Since Cn minus is a strong field ligand, that's why when the Cn minus will approach towards Ni2 plus, that will induce the pairing of electron. So let's see here. This is 3d orbital. It is 4s and it is here 4p. First like this one, then after here is like this 3d orbital. Here 4s and it is 4p. So when that will induce pairing of electrons, so this electron will come here. So now the d orbital, there will be one vacant d orbital. Here is one vacant 3d orbital, this 4s orbital, and this 4p orbital. So 4s and 4p. So one electron to form 4 sigma bond. Here coordination number is 4. That means the Ni2 plus will have to form 4 sigma bond. And to form 4 sigma bond, 4 hybrid orbital will require. And to form 4 hybrid orbital. 4 atomic orbital will merge together. Since coordination number is 4, so nickel Ni2 plus will have to form 4 sigma bond. To form the 4 sigma bond, 4 hybrid orbital will require. To form 4 hybrid orbital, the 4 atomic orbital will merge together. Here, there is one 3d orbital vacant and 4s, so only 2 orbital of p will participate in hybridization. Because 3d orbital here, one 3d orbital is vacant. One orbital of 3d is vacant. That's why only 2 orbital of 4p will have to participate in hybridization. So hybridization will be here dsp2. When hybridization will be dsp2, then shape will be a square planar. When hybridization will be sp3, then the shape will be tetrahedral. But when the hybridization will be dsp2, then the shape will be square planar. Since hybridization here is dsp2, that's why the shape will be square planar. So shape will be and magnetic behavior here diamagnetic. Since this in this molecule there is no unpaired electron, so shape will be here, magnetic behavior will be diamagnetic. Okay guys, that was about the bonding valence bond theory of the topic bonding in coordination compound. That was about the valence bond theory, which predict about the shape of molecule, the magnetic behavior of the molecule. Okay, in the next video we will discuss later on here the magnetic behavior. When you will discuss this one, already I have discussed about this magnetic behavior that has been given here in the form of stories. Then after this crystal field theory, only 2 theories you will have to study, the valence bond theory and the crystal field theory. Then after here is we will have to discuss why the coordination compound so colored about those in the crystal field theory. That explain why the coordination compound so color. But that is also here explained. We have explained. We will have to explain. And this one is here. So firstly, about that bonding in coordination compound, we will have in the next class we will discuss about the crystal field theory, and the remaining portion here about the magnetic behavior you also study by yourself, and I hope all of you will understand by when you will study this topic, that is here magnetic properties of the coordination compound. Even though if anyone will have any difficulty to understand this one, just ask in the comment box. I shall reply about your queries here. So read this one and because this topic is quite easy, as I have already explained about the magnetic behaviors in the coordination compound. So when you will study about these points, very easily you will understand. So it's all for this class. In the next class, we will proceed on the crystal field theory. Okay. Thank you, Team Educate.